Hey everyone, welcome to the Occasional Podcast. I'm your host, Brian Hunter, and you have reached us at Season 9, Episode 10. That's right, we're nearing the end of Season 9, and we want to fish it up with a big piece of flare, a flare shooting up into the sky, gracefully coming down in the letters of Andrew Jones. Now, Andrew Jones of MoFi Electronics has been around the block more than a few times, you could say. In addition to recently designing the SourcePoint 8 and SourcePoint 10 for MoFi Electronics, the man, the legend, has worked at the likes of KEF, ELAC, TAD, and even more. So we're very excited to have him back on the show one more time to talk about crossovers, a subject that is quite often misunderstood, and we very much appreciate Andrew coming on and explain it out in the way only Andrew Jones can do. So as we say, on with the show. Here we go. Andrew Jones of MoFi Electronics. Our friends at ZMF Headphones are sponsors of today's episode. ZMF is a curated collection of various sounds and styles in the form of dynamic and planar magnetic wood headphones, designed by founder Zach Merbach since 2011. ZMF has garnered an A+ recommended component in Stereophile, Headphone of the Year on Headphonics.com, and been a 2-time winner of the SBAF Golden Schlong Award. ZMF Headphones. That's the letter ZMF HEADPHONES.com. ZMF Headphones is the place to go to check out ZMF's collection and learn more. ZMF, traditional craft and modern acoustics. Today's episode of the Occasional Podcast is sponsored by Acora Acoustics, maker of high-end natural stone speakers. Acora Acoustics' goal is simple: engineer speakers that bring your music to life and bring the family together. Their loudspeakers are handcrafted to let pure sound take the stage, directly connecting you to the heart of your music and all its natural colors and vibrancy, while fitting exquisitely into your existing decor. Acora uses only the finest drivers, crossover components, wiring, binding posts, damping materials, and screws. Each component is hand-picked and screened for quality, first through meticulous measurement, and then by thousands of hours of extensive listening. They know that when it comes to audio performance, nothing short of spectacular will do. See more at AcoraAcoustics.com. That's AcoraAcoustics.com. Hey everybody, thank you so much for joining me. I'm very pleased to have the illustrious Andrew Jones join us again for the show. If you remember last season, we had him on and we discussed cabinets. We've had him on to discuss drivers. We are slowly making our way through the speaker. So if you listen to all of his stuff, soon you might be the next Andrew Jones.
I like these kind of build-ups.
I know. I feel like every time we do this, it needs to be a little bit longer. But if you guys do tune into the cabinet one, I think the intro was like 2 or 3 minutes long. We just kind of rambling on. But, really, if we're going to get down to it, one of the things that I'm seeing online a lot are these upgrade kits. So, designers will make a speaker, and sometimes third parties will come behind and say, hey, this speaker sounds really good. It kind of looks like this, but I've done this thing that you can do to improve it. And these kits can be very specific to a singular model of speaker. Well, as I was kind of looking at the pricing the other day, I noticed that some of the kits were almost or maybe just 80% of the price of the actual speaker. Now, that to me kind of signaled an interesting thought, which was, what do we put, if you're a designer, the weight of the crossover in terms of cabinet and drivers and crossover? There's like these essential elements to what contributes to the entirety, right, of the sound. And where exactly does the crossover lie? Because it's kind of implied in the pricing there that we have got a major contributor to the sound. So I thought I'd bring Andrew on the show to discuss crossovers as a whole and kind of his approach to things and how he really handles the situation, because I want everybody to keep in mind as we talk about this, Andrew and everybody who develops a product essentially has to work within the confines of cost. I think, Andrew, we've spoken on a couple of occasions about how if there were no limits to cost, what would you do or what would you like to do? But I think in a way, for that, you've really pioneered a way to bring stuff to more people by bringing the price down or working in, choosing to work within even smaller and smaller confines to produce something that's great and that more of the mass can hear. So that's where we're at. But I wanted to start it with kind of a more pull it back, right? And say, hey, what exactly is a crossover? What does it do? And what does it do in a more general terms? So let's just start there.
Well, it's interesting because we talk about the importance in speaker design of the different components. You got the driver, drivers, crossover, cabinet. And I've said in the past that my order of priorities is drivers, then crossover, then cabinet for budget speakers. And so writing a brochure for the new speaker I've done for MoFi, and someone quoted me and they said, Andrew says the three most important things about speaker design is cabinets, is drivers, crossovers, and cabinets. I'm going, I think you need to re-express that because they're the only three things you have in a speaker. It's drivers, then crossovers, then cabinets.
There is nothing else? I mean...
Well, there's the internal stuffing and there's industrial design, and obviously cost, but that's a given. And, I've done all the TAD stuff, which is, you could sort of say is cost no object. Mm-hmm. Except it isn't really. Even if you took $1 million speaker, it's odd to say that you would have competition at $1 million.
Yeah.
Right? And so you've still got to keep in mind that if you do something at what, according to your philosophy and how you wanted the design speaker, ended up costing $1 million, someone else is going to do something at that price point. So you're always in competition at any particular price point. But of course, the kinds of decisions you make and your priorities will change depending on price point. And, I said before, I've done the TAD stuff, but then I got the opportunity to do the really affordable stuff. But even that Pioneer one wasn't the most affordable Pioneer speaker I've ever done. When I first started with Pioneer, we were making some speakers to sell at Circuit City, if you remember.
I used to work there.
Oh, right.
Listeners, that's how I got my start.
So I produced the H series speakers, and those were like the 6-inch bookshelf was like $39.
Yeah.
And you have to be really innovative to get a semblance of quality out of something at that price point. But I enjoy those kind of challenges. But yeah, when it comes to crossovers themselves, everything matters, but I start with the drivers. I've got to get the best quality out of the drivers at the particular price point I'm choosing. But then you've got to knit them together into a whole. And that's obviously the job of the crossover. And you can have simple crossovers. You can have complex crossovers. You could set requirements that the impedance shouldn't drop too low, because it's very easy to just mess around with a crossover, get a response shape that you think you want. But when you look at the impedance curve, it's gone to pot. It's dropped down to an ohm. If you leave it up to these optimizers, it could drop down to an ohm or 2 ohms, because it's just picking. It's trying to get exactly the answer to one question that you've given it, and ignoring anything else. And as in all things, it's a compromise between different parameters. And so even a relatively simple crossover has bounds that you have to observe and limits what maybe you can do. Or if you do a really complex one, it's very easy to get it going wrong with these optimizers. So we use optimizers clearly, because in the old days of just having a board and keep plugging in components, it's very difficult to hone in on the right answers. With optimizers, if you don't have the starting values reasonably sort of close to what you want, then it can go wild and maybe never even optimize. So you still have to learn how a computer optimizer operates in order to get a good result out of it. But of course, first of all, you need to know, what do I want it to do? And that's going to depend on the capabilities of the drivers. So the crossover isn't just about getting a particular crossover slope. People, I'm always getting asked questions, well, what slope are the crossovers? Going, they're what they need to be. There's this idea that there's only certain slopes, or the slope of the tweet has got to match the woofer. And whenever you talk about what is the order of the crossover, that's not what matters. It's the order of the crossover combined with the drivers, because the drivers are limited bandwidth.
Right.
And so say you want a Linkwitz-Riley crossover. So that's fourth order, it's Butterworth squared. And it's not that you want the electrical components to give you an electrical response at the driver terminals of Butterworth squared. It's that the electrical response at the terminals is whatever it needs to be, such that out of the driver in the acoustic domain, you get this Butterworth squared response. Often people forget that, especially when they get these active crossover units where you can just, I'll dial in a Butterworth and things like that. And when you're trying to get whatever response you've decided is needed at the terminals of the speaker, you're operating into a very complex impedance. You're not operating into a resistor. So none of the design tables that you might get in an electrical engineering book work. And so you've got to be able to measure, right? And here's the crux. Measurements don't tell you 100% about how you think it'll sound. They're a fully necessary guide to what you're doing. But first of all, if you're going to relate measured response to what you hear, which is always a good thing, then you need to know you're measuring accurately. So what is a sufficient set of measurements to accurately describe in a speaker what you hear? And sticking a microphone in the room and gating it at 4 milliseconds is so far from an accurate response. Reversing the polarity of the tweeter and looking at, is the notch deep, is so far from sufficient to know what's going on, that trying to relate that one measurement to the sound that the speaker is producing, it's not enough, because the speaker is multidirectional. It's a 3D wavefront. The advantage of electronics, you got an input and an output. With a speaker, you got an input and an infinite number of outputs.
That's very interesting.
Right?
Yeah.
A speaker measures differently in every single direction. Ideally, we'd say, use an omnidirectional speaker. It will measure the same in every single direction. Well, first of all, there's very few perfect, I'd say there's no perfect omnidirectional speakers. There's no perfect speaker. They all fail in some sense. So if your goal was omnidirectivity, it's very difficult to get fully omnidirectional and smooth response exactly the same in all directions. If you want a given controlled directivity, you can aim for it, but if you wanted it the same directivity at all frequencies, it just isn't going to happen. Kind of acoustics preclude that happening unless it's huge. So not only have you got a different response in every direction, the way it sums between woofer and tweeter change with every direction. The response of the speaker changes with listening distance. Not only even with a small box speaker, but a line source, by definition, changes, by the acoustic analysis, changes with distance. And unless it's infinite high, but I don't know anyone who's got an infinitely high line source. The best you can do is literally floor to ceiling, and then you use a hard floor and a hard ceiling. And so reflection-wise, if you imagine it squeezed between two mirrors like that, it would look infinitely long. Yeah. But that means you've got to have tiled floor and no absorbers in the room. So as you step back from that perfect case, you've got not a true line source. It's only a line source at higher frequencies. It will revert to closer to omni at the very lowest frequencies. So all these things change with angle and distance, as does the summation. And because they do that, and you're listening in a room, not an anechoic chamber, it's fun listening. I was going to say it's a fun experiment. It's fun to learn listening in an anechoic chamber. You just don't want to. The speakers designed for rooms sound awful. I've done experiments back in the days of KEF where we set up a pair of speakers in an anechoic chamber, and the music sounds awful like that. Huh. So now you've got something in a room that is returning energy from all those other directions the speaker was radiating. And you're doing some complex processing in the brain between the first arrival sounds and early arrival and late arrival and pure reverberation. They all contribute to give you a sense of the sound balance of that speaker. And so how could one sticking a microphone at some distance in front in a typical room and trying to measure that response and gate out all those reflections, how could that possibly represent what the speaker is doing? And one of the problems that presents is if you design from a measurement perspective, which of course that's how I started, and my first role at KEF since I was in the research department was to improve measurement techniques and understand where the errors come in. So if that single measurement cannot represent the sound character of that speaker, and certainly without doing time delay stuff to see how the resonances decay, then what is sufficient? And if you wanted to illustrate to somebody the character of that speaker, how many of those measurements do you need to show that? And how many people could understand? This sounds elitist, but I'm just trying to say, if you're not experienced at measuring speakers, how are you going to look at 20 or 30 curves and different ways of measuring a speaker and balance them out to understand how that represents the nature of that particular speaker? I spend my life doing that. But just casually publishing that number of curves, is that really going to be a good way to get a sense of what it's doing? And on top of that, if you want to then say, okay, well, I think this set of parameters represents what I would hear from the speaker. Since nothing is perfect, which of those deviations from your perfect target curve represent the ones you want to keep and what you don't? And could you look at a curve and go, that's going to make the trumpet sound bright? Mm-hmm. Most people haven't really experimented with that. And yet I just unearthed it again in my lab. a graph from 1937, I think it was, GE Research in England, hand-drawn on a piece of graph paper, and it's deviations from flat in certain frequency bands. And allotted to it is makes horns sound brassier or makes voices sound muted. And 1937.
Yeah.
Things haven't really changed, but a lot of people don't have the experience of doing that. Now, sound engineers do.
Yeah.
And when
I've seen, there was a graph I shared on social where production guys, just like you're saying, they have the frequency spectrum and they say if it's you were saying up and down, but if it's just like too much of this because they're going for flat as well, like it's shouty, it's trumpety, it's bright, and then they have a descriptor to help them because it's just so immensely complex way of thinking in a way. We're like, okay, this thing is doing this thing, and then we got to assign a name because that association, and then you work. But it's just like
Harman actually may still have. There was a test you could take, a learning process. Where
I've actually taken it.
Oh, you have? Yeah. And it teaches you to sort of recognize, is this region up, which frequency range is it, etc. So this importance of the speaker is different in every direction and every distance means when I come to design the crossover, what am I asking the crossover to do? How am I asking it to blend together? How am I asking the crossover to equalize the drivers to give what I want? So in a way, the crossover has a very complex thing to do. It might look simple, but in deciding what balance it's got to give to get the sound you want. And that's just talking about the basic electrical nature of adjusting the electrical response. It's not even considering quality of components. And with component quality, there's some things that matter and some things you're spending that much money for a capacitor. When we're talking about practical cost constraints, we're always working within absolutely a price requirement. Any sales guys will tell you there are natural price points to sell at. You don't sell at $1,350. It's $1,000 or it's $1,500. It's maybe $1,250. But these oddities where you just multiply by whatever margin you need to keep your business profitable and get an unnatural price point, it's always going to get discounted down to the next natural one.
That's interesting, though.
Or like when I was working with the Pioneer, there was a price point agreed on with Best Buy. We want speaker originally $89 a pair. Now, as an engineer working on that and picking, trying to engineer the drivers to the sound quality I want, picking the components in the crossover, you're always thinking, that inductor's a bit small. Maybe I'll just wind it on a bigger core. Or heaven forbid, go to air core and cost me a lot of money in comparison for a low-cost project. So, but every cost you add because you think it might make it better is going to make you miss the target price. And the customer, in this case Best Buy, if I said, it's got to be 92, they said, no. We said 89. That $3, you eat it.
Oh.
You agreed to a certain price point that we know will be a seller at that price point. That's just the way business works. So that is my job. I've got to create it to a very strict price point very often. And so knowing the value of each component and what it's capable of giving me, or suppose someone said, put in a better quality wire. Well, if that cost me $2, in an 89. Now, would someone say put in a better wire in an $89 speaker? Probably not. But just the principle of it.
Yeah.
I have to look at everything and say, for $2, I could have had a better cone material, or I could have had this, or I could have had that. Which one has the most impact on the sound?
And this idea, it still scales, right? You're talking about small price point, but you still have to play this game.
You're
even at,
always playing that game.
Let's talk about the Source Point 10. You still had to play that game, but just with increased increased bandwidth for each budget.
Oh, absolutely.
Right?
And even so it's $3,700. In my mind of what I'm trying to achieve, and I start engineering it, and I'm costing it as I go along, and I'm hoping to get a particular cost on certain components, but it comes in a bit higher. And unless I can negotiate with the manufacturer or the process to get the price down, I have to decide, that's not going to meet that price point. And someone's going to come back to me and said, but you said you could do it for $3,700, right? And that's always going to be the case. So it's an interesting game. It is a fun game ultimately because it's testing what you can do.
I like it because in a way it's almost like it mirrors the same process that a consumer would go for all the parts. They do this same kind of debate when it's like amp, source, speaker, but you're just kind of in a way translating to driver, crossover, and cabinet. The same trifecta of like, what can I get out of each section?
Yeah.
But you're doing it on like a more micro kind of
exactly.
exchange.
And it's also the equivalent of being upsold in a dealer.
Yeah.
Oh, you like that $1,000 speaker, but if you spend $1,500, you'll get this. And you're going, but I don't have $1,500. I have $1,000.
So if I could just gently put you on the spot here, when you look at those things, again, does any of them are any of the values conflated in this equation of cabinet, driver, and crossover? Do you think that the audiophile kind of society puts too much weight on any one of those things, or is it kind of just like whatever? Like, I think the drivers, a lot of people would agree the drivers are so important because that's what they see and that's what they kind of.
Yeah.
But are you like, by the way, cabinet makes all the difference. That's why it's so important, or something like that?
It's like I say, when you're doing $100 speaker, it's very difficult to afford a really good cabinet. We were what we did with that. Yeah. I still look back at that Pioneer and think a laminated, curved-sided MDF box in an $89 speaker was crazy.
Yeah.
And if I look back, if I try and do that now, no chance.
I like what you're saying because you see it reflected in a lot of these, some of these, the approach for the market strategy where like the box is the first thing to go in terms of quality because it's the thing that has the least amount of weight in the overall sound equation.
It's not just whether it has the least weight. It's certainly typically the single most expensive part of the speaker.
More than the drivers.
Well, very often, yes. Certainly in the old days. In the old days, it was at least 50% of the cost of constructing a speaker. So, it changes depending on these days where you're manufacturing. I won't get into that can of worms. But, in the days of KEF and buying speakers from Denmark, because Denmark... buying cabinets, because that was one of the best cabinet facilities in Europe when we were actually part of Europe. But hugely expensive. And obviously the higher the quality of finish that you want,
right,
really ramps up the price. So, whereas in the Source Point 10, as an example, it's got that sculpted baffle that's 2-inch thick, 1-inch thick sidewalls, real wood veneer, blah, blah, blah. I thought that would be the most expensive part of the system. But it turned out that the concentric driver was the most expensive.
And by the way, we're talking about a 10-inch concentric driver.
Yeah. Yeah,
This is not a typical driver. Obviously,
Right.
This is kind of the unique proposition, I think, to this particular one. If you guys have a chance, the SourcePoint 10, very unique 10-inch driver. We talked about it extensively on the other podcast, but yeah, I can understand why it costs more because this is very unique. It's not some off the shelf, Today's episode is also brought to you by Woo Audio. The Woo Audio WA23 Luna headphone amplifier is engineered to deliver an impressive sound experience with an ingenious design that is not the typical audio gear black box. The amplifier is an all-tube, pure analog circuit, operating in Class A mode for a powerful, balanced sound, outstanding stereo separation, and a wide bandwidth across all frequencies, so you hear every note in the recording. No matter what music you enjoy, WA23 Luna delivers Woo Audio's commitment to a natural sound that is non-fatiguing for all-day listening. Learn more at wooaudio.com. That's WOOAUDIO.com, where better sound begins. Today's episode is also sponsored by Shit Audio. Shit Audio designs and builds audio components in California and Texas. Based in Valencia and Corpus Christi, their wide line of amps, DACs, and audio accessories fit any budget, starting at $49. For a full rundown of all their products, visit shit.com or stop by their retail store in Old Newhall, just north of Los Angeles. That's SCHIIT.com.
When I look at the myriad of components I could pick from to do a job in a crossover, beyond just typically if you want to cross over at low frequencies, you need big inductors with low enough resistance. And the practical way of doing that is laminated steel cores, just like transformers. Mm-hmm. And people will rail against, you got steel cores. Well, so does every tube amplifier. So does every microphone step-up transformer, all this kind of stuff. The only pure one is air core. Mm-hmm. But cost of copper these days, winding air core inductors, hugely expensive. And when I look at what DIYers have to pay for crossover components, it's kind of, inductors are ridiculously expensive in that market. So by the time you start tinkering with building your own crossover networks, it can get insanely expensive. The cost of some of these specialist capacitors, for example, because of the construction and the materials they want to use in, even a 10 microfarad capacitor can become huge. Mm-hmm. And you think, I can't squeeze all those big components inside the cabinet and have any air volume left. Mm-hmm. So it's only appropriate for big speakers. There's all these considerations trying to optimize it within the price point you're looking at. And then you've got that other question, always that niggling question, value for money. Mm-hmm. If I spend money on this component, I have to take it away from that. And what is that balance? So if I had an extra $10 to spare, would I spend it on a particular crossover component, or would I upgrade the driver? I'd always upgrade the driver. Now, other people might have some other priorities, and especially if you want to upgrade. I see a lot of times when people are taking old speaker designs, the vintage speakers, and saying, well, the capacitors are dried out, so you need to replace them. But while you're at it, why not put in better quality components? And that cost can become rather large, but also take it away from its original design goal.
Right.
If an electrolytic capacitor, for example, was put in the design process, those have particular characteristics, which was accounted for when you were designing the crossover. If you now replace it by a film cap, for example, it will alter, even if it has the same nominal value measured at a particular frequency, because some capacitors, their capacitance is frequency dependent, measurement frequency dependent. So you measure it and you say it's 47 microfarad. I'll get a film cap, put that in. It will have different characteristics, which results in a different frequency response. So the question then becomes, is the sound that I hear the result of an improved, so-called improved capacitor construction, or is it because I altered the frequency response? Until you do a controlled experiment there, you can't know the answer. Mm-hmm. So if you're going to upgrade things to better components, the cost, as I said in the DIY world, gets excessive compared to what I would be paying. Mm-hmm. So you put in all these different components, and unless you keep the frequency response in all directions and distances exactly the same, you can't say that the change in sound is due merely to better components. Science requires single-valued experiments to kind of say this is what's happening. And so it can be a minefield. Never mind the cost, but just working through what really is constituting a change. And actually, change is a better word. Is it an improvement or a change?
That's exactly what I was getting at. This is a big deal because this comes up in so many other products where it's like, is it better or is it just different?
Right. So I have a vision of what my speakers should sound like, right? So that's what I engineer towards, both in terms of how it should measure and how I want it to sound. And I'll pick a certain frequency balance. Some people will like that, some people won't. If no one likes it, I don't have a business. I have a hobby. I keep saying this these days. If a lot of people like it, I have a business. Doesn't mean that everyone likes it. So if someone decides to make a change, then maybe some other people prefer that. So to them it's an improvement, but is it really better? Or is it just... If you define better as pleasing you, then I have no objection. It's better if it pleases you more than what was done stock, right? But depending on what you're going to pay to do that better crossover, if I could have said, well, give me the money, and I would have designed a speaker at the $200 price point, which would knock the socks off the improved $100 speaker.
But I do think there is value to saying, and this is maybe just me, you really, really like a speaker. I can see this from a different perspective. Where you're like, I want this speaker. I don't want to lose this speaker. I don't want to buy a new one. I'm willing to put almost any amount of money into it, right, to make it possibly better or fix an issue that you're having with it. Because I have nostalgia to this particular cabinet and all that. I can see that part of it, but I totally get where you're saying, hey, well.
The issue here is... it gets back to what is better.
Yeah.
What is more accurate?
Yeah.
That is a really tricky question.
And I wanted to just kind of ask you something very generic on what you were talking about before. I think one of the things that a lot of people are drawn to when it comes to graphs, they understand, they comprehend the frequency response curve first. It's that's the most easy to understand. It's simple. It looks beautiful because in our minds, either the Harman curve that we talked about extensively, or the idea of flat. You think, well, if there's no particular peak or dip, that's better. Is there any truth in the graph that's flat? Like, is that even a goal? My personal takeaway is that it's very complex. You can't just look at one graph. But is there value to that one graph, and is there a great value to having it be as flat as possible?
So within some constraints, yes, you can certainly say something about what the speaker's doing from one of a subset of those comprehensive measurements. If it's falling under similar characteristics to other speakers you've done, right? If you know all that. So if it's a simple two-way and it's a 5-inch woofer, maybe let's say polypropylene and a 1-inch soft dome tweeter, and you've done lots of those before. So do you have to do every single measurement every time that something so similar is being produced, or can you rely on a subset of them? You can probably rely on a subset. But as soon as you drastically change, if you go to a metal cone rather than a soft cone, it will have different high-end directivity characteristics. It will have probably breakup modes that are more severe. So now you're going to have to start redoing some of the more comprehensive set of measurements in order to understand the impact that's going to have. So it's a case-by-case basis. The data for designing is the measurements of the drivers in the cabinet, right? And then let's say you put it on the popular term right now, because of Klippel, is the spinner armor. But all that means is you're measuring it at every angle. It's nothing new to do that. But it's just saying I'm going to collect data from every direction. So you put that combination of drivers into that cabinet, get that data, and now you're going to design with that. If you could, to a degree, have the same response in one particular direction.
Okay.
But it would be different in other directions. So yes, certainly in vertical directions.
Do graphs lie? Is it possible, not if you make the graph, but is it possible that the frequency response graph that's flat, can it be deceptive in the way?
Oh, totally, because it depends how you make the frequency. Making what seems to be a simple frequency response measurement is fraught with error and fraught with hiding detail. The conditions that require you set this microphone in front of the speaker and you got a floor bounce and a ceiling bounce if you're doing it in a standard environment. And so with modern techniques, you use gating. And what it's saying is, if I stop the measurement before the reflection arrives, I've got a reflection-free measurement. Hey! But the very process of gating it, the speaker hasn't actually finished responding before the reflection arrives. So gating it cuts off a significant portion of the low-frequency data of what the speaker's doing. Also, gating it now limits frequency resolution. So it's commonly said that the lowest frequency of measurement accuracy when you gate is the reciprocal of the gating period. So if it was 5 milliseconds, it'd be about 400 hertz. It isn't. Oh. It's smoothing it up to a couple of kilohertz and hiding detail. So if you got any resonances, you'd be smoothing through those and wouldn't see them. So it's nowhere near accurate enough. So it could look very smooth and very even, and it's hiding it kind of wiggling up and down. So it's very easy to be fooled by some of these rudimentary measurements that most people make.
When someone's saying, hey, upgrade to so-and-so cap, do you think that the answer to is that better is generally it's very complicated and it's easy to mess up what the original intent of the designer was by just switching out caps for different caps and crossover?
Well, you're certainly going to alter the original intent of the designer. Now, is that sacrosanct, that you can never, ever alter something? No. But you're still working off the back of all the work that was put in to get to that point. So you can always make a change. And like we said, since you can't really determine from listening the true accuracy most times for most of the recordings you're going to be using, then what you determine is, what do I like to hear? And if you make a change that you like that better, okay, but then why did you buy that speaker in the first place and then decide to modify it? Why not just start the right way and buy the speaker that sounds better to you right from the beginning. It's always this kind of strange process of arriving at the answer that you need. And like I say, trying to determine, even if it sounds better to you, well, what aspect of that change is the one that's made it more pleasing to you? And you can very easily fool yourself by thinking it's certain types of component or certain types of wire. And that's not to say they can never influence that, they have no effect. But how much of it is due to one aspect of the design versus another? And you can never determine that unless you keep that constant frequency response and the same in all directions. If you make the crossover more complicated, so you change the vertical directivity effects in the crossover range, well, that has an impact on the sound. And that had nothing to do with component quality. It would have happened regardless of the component quality used. So you have to be very careful in evaluating those kind of things.
When you were talking about the slope, and I'm assuming you meant the decay of the crossover as it rolls off, of the driver as it rolls off, is the general idea, I think it's pretty simple with the two-way in the sense that one takes over where the other left off, and then we go to a three-way, it gets a little more complicated. I'm just curious about the overlap. Does the overlap of the driver as one falls, because they're not straight lines, I'm assuming, right?
No.
One doesn't just blatantly fall off and then the next one begin. There's a decay between the two. Does that actually amplify? Like, does it, if you have two going at the same, does it sound twice as tall? Is there like a scientific way to just make the thing go poop and we got flat?
Yes, there is. Mathematically, you can determine what kind of shapes you need.
Is it two times? Like, if I have one signal, does it make it twice as loud? If they're
No, it depends on the phase relationship between them. So different crossover slopes have different phase relationships. And the reason that Linkwitz chose Butterworth squared was that they're 6 dB down, so they're half sound pressure level at the crossover point. And as you move that axis, they'll never add up to more than flat. Because some shapes, when you move off axis, you get a peak. And that's generally considered a bad idea, especially since it typically points towards the ceiling, and the ceiling reflection is audibly the worst reflection you can listen to. So, the job of the crossover, it is very complex because no driver, when mounted in a cabinet, has a perfectly flat response. It has limited bandwidth. And, maybe there are anomalies in the response that you'd like to equalize out. The crossover has to do that. It also has to roll off with the right slopes so that you get the best vertical off-axis responses and best horizontal off-axis responses. But then it also has to keep the signal away from that drive unit in frequency ranges where it is starting to go into breakup modes. Or if you don't roll off the tweeter high enough or fast enough, you start getting too much heat into the tweeter, it's more likely to burn out. You get too much excursion from the tweeter, and it's going to have extra distortion.
So it's not just that it can't produce the frequency. It's not that binary. It's actually that it can't produce the frequency well either.
Yeah.
As we get to the extent of it, it's not just that the sound stops coming. It's as the quality deteriorates as well as you push it forward. Yes.
And the reliability.
Of durability?
The durability and reliability of the tweeter, for example.
It'll start to burn up or
fizz because it's moving too far.
You really don't want to push a speaker outside of its limits.
Right.
Yeah.
So, what seems a simple thing, as usual, is very complex. And you can't optimize for just one aspect. So, very often people have, I believe in first order slopes or whatever it is. If you optimize only for that aspect, you can severely affect all the other parameters that matter. So you have to be very careful in doing that. Like I say, everything is working on a compromise. And you have to think through every aspect of that.
When you look at the components in terms of the crossover, what do you typically look for? Like, is it just the fact that you kind of have alluded that you have a trust in particular brands or particular technology within the crossover units that you reliably produces the sound you're aiming for? Or is there every time you do it, is there an A/B where like how that integrates into the total system? Is it different, or is there some type of reliability within parts specific to your needs?
There's certain things you're always going to look for. You know that if the inductor needs to be big and practical, it's going to be a laminated steel core.
Okay.
And you'll just choose the core size dependent upon the frequency you're going to be using the driver over and the power level. And you'll play around with that, because if you can have a bigger core, you can maybe wind a lower resistance for that particular inductance, so you won't be dissipating as much heat in that coil. So those aspects, wherever you can, it's better to use a film cap because they tend to be more reliable long term than an electrolytic. Lower loss factor, so why not? Although often you end up putting a resistor in series with the capacitor anyway, but it's still easier to kind of have them as separate, so you can adjust one versus the other. So, but trying to put a film cap 100 or 200 microfarad on a low frequency crossover when you're crossing over 100 or 200 hertz, you're really not going to do that. Unless you're doing a really, really high end and you have this crossover board with banks and banks of capacitors parallel. But in any practical design, you're not going to do that. But you take in, like I said, you take into account the actual characteristics, electrical characteristics of that capacitor, where it deviates from being a perfect capacitor. So in that sense, I'm not looking at brands or specialized brands in most of my designs. I'm looking at the technology incorporated into making that component. And then I'm applying the principles that I've espoused about that and engineering it to the cost level. And then if I got money spare, it's going to go into the driver or the cabinet. But it's not a brand-driven thing. I've never built a speaker where I've got, you should look at my crossover. It uses that brand's capacitors, unless I've just had them labeled for my brand. Right?
No, I think that's interesting because, in my interview with Nelson Pass, he had alluded that he had found a box of JFETs that he just loved the sound, and someday he hadn't done it, but someday he was going to build an app around the sound of this particular part. And I'm just curious if that is true for more components, or if it's maybe just him really liking this thing and wanting to do this thing. But I associate that personally with the idea of brand, because he's saying this specific.
It wasn't because it was a brand
of JFETs. Yeah.
Those JFETs were produced at a particular time with a particular process,
Yes.
and they had particular electrical characteristics, which when he put it into a simple circuit would give him a degree of linearity that was relatively easy to obtain. Or then non-linearities were particularly acceptable type of non-linearity. So that it wasn't that it was. Let's pick a name. It's not that it was a Toshiba JFET. It was Toshiba had made that JFET.
Yeah.
But it made it with those particular characteristics.
Yeah. Anything you think people should know before we kind of wrap up here about crossover units, or maybe why you choose to do the things that you do, or one of my favorite things to kind of toy around with is any misconceptions that you tend to see out there that you might be able to shed some light on?
I was going to say one of the important other aspects of the design is how you lay out the components, because they will interact, especially inductors, they will interact with each other. If you don't get the right signal path for some people like to hardwire the component, the wires from the components directly to other wires, rather than putting on a printed circuit board. You'll get arguments all day long about whether printed circuit boards affect the sound or not, so they prefer to hardwire. But even given that, if you have two inductors close together, they will interact. So either they'll couple to each other in the frequency band that they are both active within, or they'll couple, like a mid-range inductor could couple into a tweeter crossover inductor. So some of the mid-range sounds are going to be transformer coupled essentially into the tweeter, which clearly you don't want because you were trying to. The whole job of the crossover was to not let those signals
it's
through.
literally the purpose.
So there is not just an art, there's a science in how you orient all those components so they don't interact with each other. And also you don't want them to vibrate. At a micro level, a capacitor is kind of a capacitor microphone. Unless it's solidly built. It could have some low-level measured microphony, but in a loudspeaker, the voltage and current levels are so high, you're never going to kind of notice that.
And this is something that maybe not all the people who are in the budget realm kind of realize, but is there any kind of implementation of this microphonic idea with the spiked feet on a speaker? There's, for those who don't know, a lot of high-end speakers will have spiked feet, and it's about vibration. Is that something that's like you're saying, well, we don't want, even these components shouldn't vibrate?
Okay, so the first thing to say about spiked feet, the most common misconception is spiked feet isolate the speaker from the floor. No, they don't. They do exactly the opposite. They couple it as closely as possible to the floor. They will guarantee the floor vibrates. So they think of them as an energy diode because it's coming to a point.
Right,
no such thing. So what they will do is stop it rocking to a degree, right? Because the speaker's moving back and forth. The coil is pushing against the magnet. So in theory, at low frequencies, you could get rocking motion if you put it on a soft surface. But the alternative of spiking it to the floor so it won't move just puts all that energy into the floor. So the floor vibrates, especially if it's a suspended wood floor. That can actually feel fun when your feet tickle because the bass is coming through the floor. Not hi-fi, but it's a nice effect. But yeah, if you're talking truly about isolating, you should be mass spring isolating, like they do with turntables. Every transducer works in reverse. Every electroacoustic transducer, you either put energy in and get mechanical or acoustic energy out, or you wiggle the thing that was supposed to be moving and you'll get electrical energy coming out the other side. You can use a loudspeaker as a microphone, and it's a very, very sensitive microphone. In fact, you can use one, if you have a pair of speakers, you can use one speaker to measure the other. And the overall frequency response, you don't even need a calibrated microphone when you do that.
Yes.
And the average, the frequency response is the average of the two. It's a fun thing to do.
Because you can use, if you just straight up plug a headphone in, you can use it as a microphone too.
Yes, you can.
It doesn't sound so awesome, but it definitely
because it's not
works.
Optimized for that particular function. But technically, it could be. It's a diaphragm and a coil. But yeah, in terms of speakers, spikes do couple, they do not isolate.
Yes, okay.
And I'm not saying which you should do. I'm just correcting the term of what people think is happening.
Is it marketing, or is there truth to the idea of spikes on individual components then as we put them on the shelf? So like spikes will also be hard spikes, right? Non-isolation. You can buy isolation, but a lot of times you'll see spikes on higher end components. Is that marketing, or is that?
Anytime you spike something rather than putting on rubber feet or just the whole surface resting on another surface, you're altering fully the mechanical vibration properties of the device, the casework or the cabinet. Because you put, especially with spikes, you constrain particular sections of the cabinet to not move because they're coupled to another heavier, immovable object. So then the vibration modes in the cabinet will change, in theory. Are they that audible? Don't know. Transferring energy to a floor, definitely audible. Isolating the speaker from the floor with the spring mass type system, definitely audible. And when we talk about these ideas of what is the correct way to do things, there's always opposing ways of doing things. Is the perfect speaker omnidirectional, or is it controlled directivity? Should a speaker be coupled to the floor, or should it be isolated? But if you take the goal of coupling it to the floor is it will not move. The goal of isolating it will move, but perfectly at all frequencies, so you don't notice it, right? The question is, you're not going to achieve either of those goals perfectly. So it's in the imperfections, once again, that determine whether one choice is better for you than the other. So theoretically, you could macrame a bag to put your speaker in, hang it on a hook from a spring on the ceiling, and it's free to swing. That gets pretty close to a freely suspended mass. And that can actually work very well. And I can just hear everyone throwing up that. What did Andrew just say? That can't be, right? But there are many different ways to approach particular ideals.
Andrew, thank you so much for coming on the show again. I appreciate it greatly.
My pleasure. It's fun.
The Occasional Podcast is a production of the Part-Time Audiophile Network, which includes parttimeaudiophile.com, The Occasional Magazine, the PTA newsletter, and audiohead.com. You can stay in touch with us on Twitter, Facebook, Instagram, and YouTube. The Occasional Podcast is produced and hosted by Brian Hunter, executive produced by Scott Hall at PTA Productions. The Occasional Podcast and its original associated music is monitored, mixed, and mastered on the Focal Trio 6 BE studio monitors. If you haven't already, please subscribe to The Occasional Podcast on iTunes, Google, Spotify, or wherever your favorite podcasts are downloaded.